Welcome back to All This Math. This is Professor Parker. And make sure you're subscribed to the All This Math YouTube channel. Make sure you like this video, drop a comment below, and please share the video with some other people. All right. What we got here? Today, we're going to be finding the LCM of these three numbers. Before we get started, I want to make sure all y'all know what an LCM is. It's an acronym. It stands for least common multiple. Least common multiple. Some people might call it the lowest common multiple. All right. What that is, it's like a meeting point. Like where is the first or the smallest whole number that these three numbers can meet up at, right? That's going to make more sense after I go through my whole explanation for this. Now, multiple. I also want to emphasize this. What's the difference between a multiple and a factor? A multiple and a factor. Factors are numbers that get multiplied to make a multiple or a product. Multiples and products are synonymous, right? Multiples and products are the same thing. They're the result of multiplication. All right. Factors are the numbers that get multiplied. All right. Let's take the number 6 as an example. The number 6 has 4 factors: 6, 1, 3, and 2. Because 3 times 2 equals 6. That's 2 factors. And 6 times 1 equals 6. That's another 2 factors. Now, one thing you should be aware of is that every number has itself as both a multiple and a factor. I'm going to say that again. Every number has itself as both a multiple and a factor. Let's go back to 6. Let me break it down for you. 6 times 1 equals 6. That means that 6 is a factor of 6 because 6 is one of the numbers that can be multiplied to make 6. All right. Again, 6 times 1 equals 6. That means that 6 is a factor of what? Of 6, of itself. However, at the same time, because 6 times 1 equals 6, 6 is also a multiple of 6. It's the result of multiplying 6 times 1. Just like 12 is a multiple of 6 because 6 times 2 equals 12. 18 is a multiple of 6 because 6 times 3 equals 18. 24 is a multiple of 6 because 6 times 4 is 24. And you see the pattern? Right. All the way up to 36 and 72 and wait, 72? Yeah, because 6 times 12 is 72. Right. Thought I was tweaking for a minute. But anyway, yeah, so make sure you understand the difference between multiples and factors. Multiples and factors. All right, let's get started. So the method that I want to use to do this, because as with many math topics, there are many different methods that we could use, right? We're not going to use the prime factorization method where you do the prime factorization of each number and then you set up the table. We're not doing that on this particular video. I'm going to show you a method I like to call the Lumumba method. Where I get that name from this brother right here on my t-shirt. I'm saying it with my chest. This is the late, great Patrice Lumumba, who was a rightly elected leader of the Congo back in 1960. Unfortunately, he was assassinated by European powers and also the United States, right? Because of the fact that he was promoting Pan-Africanism and essentially African people having control of the land and the resources in their own countries, right? Of course, colonizers don't like that because they want to control your land and your resources, right? A lot of the unrest that's going on in the Congo right now, as I speak and record this video in 2025, has to do with the same issues that Lumumba and his people were fighting against back in the 1960s, right? So to honor their ancestor, I'm going to call this the Lumumba method. You'll see why. All right, so look. So we got 3 numbers, 7, 18, and 21. All right, so we want to find the least common multiple between 7, 18, and 21. So what I'm going to do is I'm going to rewrite these numbers. I'm going to write a 7, leave some space, write an 18, leave some space, write a 21. And then I'm going to write an L. That's why I call it the Lumumba method. Because the symbol we use looks like a big L. All right, like the rapper from Harlem. Big L. Rest in peace to Big L, by the way. All right. Now, what do you do here? Look at the 3 numbers. You're looking for a common factor. That's why I had that conversation about factors earlier on, right? So we got to understand the difference between factors and multiples. To do this method, we need to know the factors of numbers. So, and we only need to pick a factor that is common to 2 of the numbers, right? So notice how there's no factor besides 1 that all 3 of these numbers have in common, right? But however, 18 and 21 have a common factor of 3 because 3 is a factor of 18. 3 is also a factor of 21. With 7 and 21, they have a common factor of 7. right? But 7 and 18 only have a common factor of 1. But you only, for this method, you only need to find a common factor of at least 2 of the numbers, at least 2 of the numbers. So I'm going to use, let's say, 18 and 21, because 18 and 21 have a common factor of 3, meaning I can do 3 times some whole number and get 18, or I could do 3 times 6 and get 18, and I can also do 3 times 7 and get 21. All right, so you take that 3 and you write it out here. All right, and then you divide each of the numbers by that number. Right now, except for the 7, you don't divide the 7 by 3. Why? Because 3 is not a factor of 7, so you don't basically you don't mess with the 7. All right, all you do with the 7 is just bring it down to the next level. But we are going to do 18 divided by 3, which is 6, and we're going to do 21 divided by 3, which is 7. All right, so now we got 3 different numbers: 7, 6, and 7. All right, now we're going to repeat this process because it's all about patterns, right? So we got 7, 6, and 7. All right, 7, 6, and 7. Now we're looking for a common factor of 2 of these numbers. So 7 and 6 don't have a common factor besides 1, but 1 don't help us. 7 and 7 have a common factor of 7. So we're going to use that. Draw another L. So we do 7 divided by, well, let me write my factor. My factor is 7, right? So then we do 7 divided by 7. That's 1. Put the 1 down here. We don't mess with the 6 because 7 is not a factor of 6. We just bring the 6 down, just like we brought the 7 down up here. Then we do 7 divided by 7 again. You get 1. And now once you get to the point where you have ones, or you have a group of numbers where the only common factor of even 2 of them is going to be 1. Like 1 and 6 have a common factor of 1. 6 and 1 have a common factor of 1. 1 and 1 have a common factor of 1. When you get to a situation like that, that's how you know to stop. That's how you know to stop. And now the next step is going to be to draw another L like this. You can get creative with it, get artistic with it if you want to, you know what I'm saying? And now you got, it's kind of like the lattice method of multiplication, right? Where you take the numbers outside on the left side and the bottom, and you're going to basically add them together. Well, actually not even add them together, but those are going to be the digits. In the lattice method, those will be the digits of your product. But in this case, you're going to actually multiply these. So you're going to do 3 times 7 times 1 times 6 times 1. So what is 3 times 7? Make sure you know your multiplication facts. 3 times 7 is 21. Then 21 times 1 is 21. And 21 times 6. Now, I want to make sure you understand how to do mental math and multiply a 2-digit number by a 1-digit number. So 21 times 6, right? This is how I do it, right? So I got 2 hands, right? I break 21 down. Some textbooks will call it decomposition or decomposing. I'm going to decompose 21. I'm going to break it down into 20 and 1. Now, why am I doing it? Why 20 and 1? Because 20 is the biggest number that is less than 21 that ends in 0. 20 is the biggest number that's less than 21 that ends in 0. That's why I'm breaking it down into 20 and 1. 20 plus 1 is 21. I decompose it, break it down into 20 and 1. Now, also, if you deal with numbers that end in 0, your math is going to be easier. We often call those happy numbers. I call them HAPI, happy numbers. Happy as in the Happy River in ancient Kemet, which is now known as Egypt today, right? But in ancient Kemet, is now the Happy River is now known as the Nile River. That's the river that our ancestors lived off of in ancient Kemet, right? So the Happy River, right? We have happy numbers because it makes the math easier. So we do 20, we take one multiplication problem, we break it down into 2 easier multiplication problems, and then we add the products together. So 20 times 6, and we're going to do 6 times and 1 times 6. 20 times 6 and 1 times 6. 20 times 6 and 1 times 6. Now 20 times 6 is just the same thing as doing 2 times 6. We could pretend the 0 not even there. Do 2 times 6 and then attach the 0 to that product. If you know your multiplication facts, which you should, you know that 2 times 6 is 12. So you just attach a 0 to 12, which is 120. 120, right? Attach a 0 to 12. That's 120. And then you do 1 times 6, which is 6. You add the 2 products together. 120 plus 6 gives you 126. All right. So then that means that is your LCM. 126. So what is 126? It's the LCM. What does that really mean? That means that this is like a meeting point for these 3 numbers. Imagine these numbers are like people, right? right? So conceptually, where can 7, 18, and 21 all meet up at, and they can all multiply by whole numbers, not fractions, not decimals, in order to get to that number. 126 is the closest place they can get to. It's the closest number they can get to where they can all meet up at. All right. 18 can get to 90 by multiplying by 5, right? Multiplying itself by 5. But 21 can't do that. 21 can't meet at 90. 7 can't meet at 90. You ever be trying to like go somewhere with some people, you trying to coordinate, you trying to meet up with people, and you trying to figure out like what's a good meeting place, and you be like, all right, well, meet me over here. And they be like, nah, I can't get over there for whatever reason. And then they might offer a place and be like, look, how about you meet me over here? And then you be like, nah, I can't go over there because of whatever reason or whatnot. Or I don't like driving over there, or that's too far, or whatever. It's the same thing with numbers. They trying to get to a common multiple. The best, but you got to figure out what that meeting place is. Just like when people got to figure out a good meeting place, numbers got to figure out a good meeting place. So the meeting place for 7, 18, and 21, the closest meeting place is 126, right? Because you could do, what's that? 21 times 6 to get to 126. You could do 18 times 7. Yeah, you could do 18 times 7 to get to 126. And then 7 times 18, right? 18 times 7, 7 times 18 to get to 126. But 126 is the closest meeting point for all of them numbers where they can all meet up at. All right. So that's just a way to think conceptually about what is an LCM really? What is an LCM? Because it's cool to be able to like know the methods and know the Lumumba method and all that, find the common factors and then multiply the numbers. But I want y'all to really understand the concept behind like what does this really mean? Like what does a common factor really mean? What does a common multiple really mean? A common multiple is basically a meeting point, right? It's where all these numbers can meet up at, the closest place they can meet up at, right? Where everybody gets multiplied by a whole number, not by a decimal, not by a fraction, but by whole numbers. All right. Whereas each of these numbers is also a factor of that number. So just something for y'all to think about. All right. Stay locked in. I'll see y'all on the next video.